Hey guys, I gotta tell you, this is one of my favorite lessons. This and lesson 14, so lesson 13 and 14 here in module 4. Uh, some of my favorites of the year. I like the discussions we have about them. I like the creativity you show in problem solving, and um, they're just sort of we get to talk about some fun practical examples in class. So um, let's get started. All right. So I sort of talked about this earlier in the week. I sort of gave you a heads up that this is where we were going. And you see that we're going to find the area of this like whole figure one right now. Let me get specifically on that one. So you're just focusing on that figure one. That's what I'm going to find right now. And notice we can't just multiply side lengths right now because over here, this isn't like 1, 2, 3, 4, 5, 6 rows of 1, 2, 3, 4, 5, 6. It's not 6 rows of 6 because we're missing a big chunk down here. So what you can see is that they've split it up into two rectangles. You have a 1, 2, 3, a 3 by 6, and a 1, 2, 3 by 3. So actually, I think you can hopefully see down there at the bottom a little bit. It says area A plus area B is 18 square units. 18 comes from 3 times 6 equals 18. And 3 times 3 equals 9. So my second part would be 9. 18 plus 9 is 27 square units. Let's do one more of those. Let's do part figure 2, this other one right up here. So in figure 2, I have a 2 by 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have a 3, 1, 2, 3. Again, I'm only counting from right there to right there times 1, 2, 3, 4, 5. Well, 3 times 5 equals 15, and 2 times 9 equals 18. So I'm going to come down here and say that I have 15 square units plus 18 square units, which adds up to 33 square units. So the entire area of figure 2 is 33 square units, but I need to find these two parts independently, almost like they're in completely separate problems, right? You look at them almost as completely separate. You do look at them as completely separate rectangles, and then only at the very end do you think about them being the same in any way. So that's how you're going to start. That's sort of the introduction. That part's pretty straightforward. It's kind of especially straightforward when they break it apart for you, show you where A and B are. But eventually, we switch gears and we get into something like this. So I think of this as like I don't know, a piece of paper that has a piece cut out at the bottom, right? So you're trying to find out how much area you have left to draw on because this piece is missing right here. And you're like, well, how do I how do I find that if there's a piece missing? Well, couple of different ways you can do it. Uh, In this case, a longer way and a shorter way. I'm going to show you the shorter way. I would think of, let's pretend that piece was there for a minute. Let's pretend it was there. If it was there, it would be 9 times 10 equals 90 square centimeters. So I'm going to put 90 right there. If everything was intact, if it was the whole piece of paper was there, or the whole shape was there. However, we have this cutout in the middle, and it's 4 centimeters times 3 centimeters. 4 times 3 is 12 square centimeters. So I need to subtract 12 square centimeters from my 90. Because when I said 90, I didn't actually have 90 square centimeters of space. I had 90 square centimeters of space minus some amount that had been cut away. And that amount was 12. So I end up with, let's see, I end up with 78 square centimeters worth of space. So this is slightly different than the work we did on the front. On the front, we just cut cut the shape into two rectangles and added those pieces together. Well, sometimes you have to pretend like you have an entire rectangle and then go back and subtract out part later. It's in a way similar to when we're doing 9s facts and we turn them into a 10s fact and then subtracted one group of whatever after the fact. It's the same basic strategy that you're using now, just with area. Now let's take a look at this last one on the page here. And we're going to go, this lesson I should have said at the beginning, or maybe I even did. It's like a 2-day thing. So we're going to go over this again tomorrow. So we're going to go over it once today, once tomorrow. We may even spend another day on it because it is interesting and it does pose some challenges, and I want to make sure that we're understanding it. So on this one, you'll notice that we have this shaded rectangle that we need to find the area of, and there are 2 different ways to do this. I am going to show you both ways on this one. So the first way is to subtract, find the area of the whole thing and then subtract out this. But we don't know what the 2 dimensions are of this unshaded part, this part that's not actually in our rectangle. So I need to figure them out somehow, and this is where things get interesting. I know that the entire length on the bottom from here to here is 9. So if I added from there to there, it needs to be 9, right? Because in a rectangle, opposite sides share a common side length. Well, if from there to there to there is 4, I need 5 more to make that 9. So I found my first side length. I'm going to do the same thing over here. The entire side length over here is 7, which means the entire thing over there needs to be 7. Okay, so let's see. I could do 3 plus, it must be 4, because 3 plus 4 is 7, and it has to be 7. Well, now I can say that I have the area of the big rectangle is 7 times 9, which is 63 square centimeters. And the area of the small rectangle is 5 times 4 centimeters, which is 20 square centimeters. So the area of the shaded figure is going to be, I'm going to do it up here because I need space for something else later. 63 minus 20 equals 43 square centimeters. That's one way to do it. The other way to do it would be to do something like this. Take this rectangle and turn it into 2 rectangles. Now I have a 4 by 7. 4 times 7 equals 28. And I have 3 by, well, we figured out that that was 5, because again, if this whole thing is 9, right? And from there to there is 4, the leftover piece is 5. 5 times 3 is 15 square centimeters. So I do 28 plus 15 is 43. I got ahead of myself there. 43 square centimeters. So there's 2 ways to approach this problem, and I encourage you to try both and see which one. You're going to need both, because some situations will sort of be easier to use one than the other. So practice using both, but you probably will develop a preference for one way over the other way. So I think it's important that you learn both. I think it's important that you practice both. So in this case, you could either add to the rectangle, the whole, make it a large rectangle and then subtract out this portion, or you could find a way to cut this into 2 pieces and add those pieces together once you are done. So both of those ways work. Not to complicate things further, but we also could have cut it this way and made a long skinny rectangle here, a short small one up top. So there's all kinds of different ways to solve these problems, which is why I love these types of lessons, because you guys generally have really good conversations about the different approaches you're using to solve problems, and we get into some really good discussions about which are the most effective and which are the most efficient. And I get to watch you guys and help you guys uncover your own personal preferences for solving problems using the strengths that you have. So it's a fun lesson to teach. I hope it's a fun lesson to learn. In the future, a lot of these we'll talk about, like measuring the area of a pool deck, but taking out the pool, obviously it's the middle of it, things like that. So we'll have some fun ways to think about why we might need to know these skills sometime in the future. All right, guys, I enjoyed that lesson. I hope you guys did too. And we're going to do the same thing basically tomorrow. So get some more practice tomorrow with it.